Good evening, everyone. I welcome to the second and the last live session of the course, Multi-Core Computer Architecture, Storage, and then Interconnects. We have received a couple of questions already from the student participants, and you are now free enough to chat your questions over here. And we will be taking on your live questions as well. In the meantime, whatever questions that is already posted by you, I am just compiled and we will start discussing on it. Kindly add on your questions and we will be taking these questions and try to answer as much as questions as possible. I hope by this time you have already gone through all the videos of this course. All the 20-hour video is now online. In another 10 days, you will be having the certification exam. Kindly do prepare well. I wish all the candidates the very best. Work out all the assignment questions that is posted on all the 8 weeks. We don't be having any questions based on Gem 5. It's only based on the remaining topics. Gem 5 is only for the practice that is being given. And so with that, we will go. Let me take up the slides that will help us to. Okay. So this week, majority of the questions are from the network on chip architecture. So let me go to the very first question. When we are using chipper that removes the requirement of two-stage priority sorting and selects a golden flit, how is the golden flit chosen? So this is the first question. So it is already mentioned during the lecture about that golden flit is being chosen by the oldest flit and by a round robin mechanism. So to elaborate a bit, first the router number 0 will be choosing one of its flits as golden. The moment the flit is golden, then it is no longer going to get deflected. So then we know that by what time the flit will reach the destination. And once the flit reaches destination, say at time t, then it is the turn of router number 1 to pick up the golden flit. So every router will get a chance to pick up the golden flit, and there exists only one flit that is golden in the entire network. So the second portion of the question, will the selection be based upon timestamp or it is in a round robin manner? If it is timestamped, will it require comparing circuit? So this selection is not based upon timestamp completely. Each router is given the responsibility for picking up, which is the golden flit. And at any given point of time, there is only one golden flit in the entire network. And once the golden flit reaches the destination, it is now shifted to round robin manner to the next router to pick up who is golden. That is the answer for that question. Now we are moving to the second question. In the case of chipper, is there only one golden flit for the whole of the NOC, or there exists one golden flit for each router in a particular cycle? The answer to this one is we have only one golden flit. That is the correct answer. Only one golden flit in the entire network. Now the second portion of the question is, if there is only one golden flit for whole of the NOC, will it not affect the traffic at the other routers at that time? Because all other flits at other routers might not get proper output port. So I appreciate the candidate who raised this question because he has gone deeper into the concepts. Let me take some time to clarify this. For others who have not been comfortable with this question, I will rephrase the question once again. Is there only one golden flit in the network? Yes. If there is only one golden flit, what about the remaining routers? So at any point of time, only one router can handle golden flit. All the other routers will be handling only non-golden flits. So those routers which are handling the non-golden flits, there is no priority mechanism. All the flits are equal, and that may result in more amount of deflection. So the candidate's concern, because all other flits at all other routers might not get proper output allocation, is a very valid point. And we have to understand that whatever we have learned in deflection routers, like the chipper router architecture, these are all research materials, research papers published. So when this paper, chipper, which was published in 2010, at that time, that was the very first work in that. Of course, all this work may be having its own drawbacks. Over the period of time, researchers have worked on it. Probably the other routers that you have seen in the course, MinBD then D bar, slider and all are working on the drawbacks of the first architecture chipper. So of course, when you propose a very new idea in any domain, that will be always a promising idea. At the same time, it may have drawbacks. So surely chipper has its own drawback, but chipper was the very first bold step which is giving into the domain of deflection routers. Let me move to the third question. For virtual channel flow control, is buffer fragmented into multiple parts? So I have shown a diagram on the right side. This is your virtual channel router. Your flits are going to come from various directions, north, south, east, west, and local port. And the first point of entry in the router is your ports. This is the ports. Now, in the ports, you have the virtual channels. What you see here is the flit that is going to enter will sit either in VC0 or VC1 or VC2. The number of the VC is being determined in the previous router itself, which is called virtual channel allocation. Now, what you see on the left side, this blue is entirely one virtual channel, and this complete virtual channel is being further subdivided into smaller flit buffers. So the question that is being raised by the student for virtual channel flow control is buffer fragmented into multiple portions. Yes, virtual channel, we have parallel tracks. That is called virtual channel. This is virtual channel number 1. This is virtual channel number 2. Now each of the virtual channel is internally divided into a FIFO structure where each of the smaller one can accommodate one flit at a time. So that's all about virtual channel flow control. Now the next question is the notion of pages used in caches, like X number of pages stored in a cache. What is the relation between virtual page number, which is translated by TLB in a virtually indexed physically tagged cache, and the tag field that is stored in the cache entry? So generally, all the cache memories of modern processors, we are actually working on physically tagged caches. So let me try to explain. When processor gives the address, it is known as virtual address, which consists of a page number and an offset. And using the help of TLB, we are going to translate this into frame and offset. The same offset is being used. The same offset is being used. Now, once you get the physical address, then you are going to divide the physical address into tag, index, and offset. So the question is, what is the relation between virtual page number, which is translated by the TLB in a VIPT cache, and the tag field that is stored in a cache entry? So here we have to understand that you have a page number. This page number is being translated by TLB, and you are getting the frame number. And mostly your tag entry is a portion of the frame number. So once you get the physical address, then the most significant bits of the physical address is your tag. So in virtually indexed physically tagged cache, you are not waiting for the translation. With whatever is the offset that is available, you are going to, because normally the I and O portion will be completely contained in this D, whereas this D, okay. So if that is the case, then you can perform indexing prior to translation. So that is called virtually indexed. Now, by the time I index into the cache, the translation is done. You got the frame number. Once you get the frame number, then the most significant bits of the physical address is available. That means tag is available. So pages is a concept that is used in operating system for handling virtual memory. And once you get the physical address with the help of translation look-aside buffer, then you are able to get the tag. So we move on to another question that is asked in network on chip. Is dimensional routing a combination of east first turns and west first turns? So what you see in the slide is an 8x8 mesh network, and I have captured your west first turn and east first turns. In the case of west first turns, what are the two arrows are missing? So I will draw it with the help of a red color. This arrow is not there, and this arrow is also not there. So these are the two arrows. One is northeast transition, other one is southeast transition. These are prohibited. Southwest and northwest transitions are prohibited. So this is basically northwest transition, and this is southwest transition. Similarly, you have a northeast transition is prohibited and a southeast transition is prohibited in the case of east first turn. So the idea of west first and east first is if you wanted to travel either to west or east, depending on the case, you have to take it initially. Once you take any non-west turn, then you are no longer allowed to take a west first turn. That is the idea of west first and east first turn. But the question is dimension order routing a combination of east first turn and west first turn? Yeah, actually it is it's a combination of east first turn and west first turn. But nowhere in any of the literature, this kind of a direct description regarding this is given. But from the underlying concepts, it is clear that we are taking only X direction first, followed by the Y direction. So next question is based upon DRAM. I think this is the only question that is asked from DRAM. In case of FRFCFS, the reordering of the queue takes place as the different requests have the same row loaded into the row buffer. So I find some kind of mistake in the sentence. Actually, the idea is not conveyed, but whatever I understood from this, I will try to answer. So the candidate is trying to ask about if you are following FRFC, the FCFS, that is first ready, first come, first serve, then some of the misses, cache misses that comes to the main memory, they will get penalized. So since the request of a particular instruction is being reordered to the last, it has to wait for longer. In this case, can't it affect the performance of CPU? It's a very long question. Let me try to rephrase it, what I understood. If you are following FRFCSS, then there is no guarantee that the request that is coming to DRAM will be processed in first come, first serve order. We are going for first ready, then first come, first serve. So what is mean by the concept of first ready? If there is a request which is to currently open row buffer, then that request is being granted first. Whereas any other request, even though it is coming first, but it is that is to a different row, in order to service that, first I have to close this row. That means pre-charge this contents of the row back into the DRAM rows and then activate a new row. This process of pre-charging a row and activating a row is a time-consuming as well as power-generating process. So if you use FRFCFS, then what the scheduler does is, once I have serviced the request, I look into the set of available requests in the queue. If any of the requests is to currently open row, that is being serviced first. And then only I am going for this. The concern that the candidate raised, so in that case, let's say some of the requests from an application has reached first, but it is not belonging to the open row, the request can get penalized and the processor may stall. Yes, the observation is correct. The processor will stall. Will it affect the performance of CPU? So when you define about performance of CPU, it is not about the stalling of a single application. We have to understand that we have a common DRAM and we may be working on a multiple programs at the same time. So different programs are running in a multi-threaded or hyper-threaded or multi-programmed way. Many of them will generate last level cache misses. They will come to DRAM. So the DRAM queue may have many such requests that is pending. So once you have such kind of pending requests, then the DRAM controller will take only those requests which are kept open in the row buffer. Performance will be tampered, but we have to see on an average case. If we go only as per FCFS, then there may be cases such that your first request is from row A, the second request may be to row B, third request is again to row A, and the fourth request is to row B. So consider 4 requests which are of different rows coming in an alternative manner. If we go as per FRFC, if you go for first come first serve, then I will activate row, will come down to the row buffer, then it is being serviced. Then I am going to pre-charge it back because the next request is to B. So in order to get an average better performance, whatever row is currently available, then that all requests pertaining to that row is first entertained, and then only we are moving into the adjacent one. So for a single application, it may stall, but considering the overall performance, it is not going to create any problem. So that is the answer for this. Let me go to the next question. So this was a feedback about the course. It was a good course on processor details, and I would like to know about a future course planned on NPTEL. So there are many courses in NPTEL. So I'm just assuming that this question is specifically about whether am I offering any other course. Yes, we are in the process of offering more flavors of computer architecture in subsequent semesters. But in the January semester, there is no course from our group. In the next July 2019, we are planning for advanced computer architecture course. We are waiting for the approval from NPTEL authorities. Once approval is there, you will see that course that is floated in next July semester. It's also a 20-week course where you have more emphasis on pipelining. Okay, so we wait for NPTEL updates regarding that. Next question. So we will come back to all the questions that is being lively posted now. We are just compiling it all. Once I have completed all the questions which are posted early, we will come back to all the questions that are being typed by me, because I can see that there are a lot of questions that are being coming live now. We are just compiling it. So kindly wait. If a virtual address mapping is present in TLB, does it mean that the corresponding data has to be present in any of the caches? Okay. So this is if you have a virtual address mapping that is present in TLB. So why is TLB used? TLB is used for converting a virtual address into the physical address. So once you get the physical address, then only you can divide into tag, index, and offset. So the question is, if somebody is getting a hit in TLB, does that mean that it is present in the cache? No, we cannot give a guarantee that if something is a hit in TLB, it is going to be a hit in the cache. Because you have to understand that TLB is very small, only very few entries can be populated in the TLB. TLB contains the most frequently used page table entries. So TLB, if it is a hit, means you have already obtained the physical address, then you can go to the cache and then search for. Sometimes even if it is present in TLB, it may be missed in the cache. That can also happen. So there is no direct correlation between whether something is a hit in TLB or it is having a direct correlation with the presence in the cache. Next question, the second level TLB consists of both instruction and data addresses. Does the second level TLB give any higher priority to instruction or data? How does the second level TLB provides a fair space for both instruction and data address to be stored in the second level TLB? Okay. So a very good question. I think I will just try to summarize what this candidate is looking from this question. You have multiple levels of TLB, just like multiple levels of cache. So the second level TLB is going to tell us what are going to be the physical addresses prior to accessing the L2 cache. And there we don't have separate ITLB and DTLB. It's a unified TLB. And this TLB is going to provide us the physical address for the virtual addresses that are available in this TLB. Since the TLB is going to be shared by address and data, the concern raised by the candidate is how will you ensure that there is a fair share that you are going to get for instruction and data? Generally, such a kind of restriction is not done. The definition of TLB is TLB contains the most frequently used page table entries. So you are going to use more of entries of the instruction. The possibility that more entries from the instruction side of the page table will occupy TLB is very high. So depending upon the usage, if you are going to access more data, TLB contains more data page table entries. If you are having more access to the instruction side, your TLB has more of the instruction page table entries. So as of now, there is no any fair space allocation. So there is a very specific long question. I have a question on multi-core caches. Caches works well when there is a spatial or temporal behavior in the program. So caches are going to work well as long as you have a good temporal and spatial locality. Instead of cache, if it is made into internal memory, then the user has more control and can use the DMA to bring data from main memory to internal memory. This guarantees no cache miss and provides better performance than encountering miss and bringing the data. I have a small concern regarding this. I'm not sure what this candidate is looking by the term internal memory. Is it memory that is available inside the processor or some other hierarchy of memory? Let me address it as an internal memory is a memory that is inside the processor. Then your DMA can bring from main memory to internal memory. The purpose of DMA is not copying from main memory to internal memory. DMA basically transfers from IO to main memory. That is a functionality of DMA, and DMA operates at the speed of front side bus. And DMA, as of now, the most latest DMA controller also do not have any mechanism by which it can populate data or instruction into a memory available inside the processor. So DMA cannot help in this case. In future, there may be techniques similar to DMA. There may be techniques something like DCA, direct cache access. So if such a kind of a technique comes in future, then you may have mechanisms by which you can populate more amount of data into the caches without encountering any cache misses. So the notion of if you have an internal memory and you have a circuit that is going to populate this will improve performance, that is still not so realized in the architecture community, but people may be working on this. So there were a few questions general that because since some of you are seriously preparing for the exams, you have any pattern for mock exams? That is a question. Any mock exams, any question paper pattern, any mark split up? Okay, so to be unfair to our candidates, we are not going to put up any mock exams. But if you go through the weekly quizzes, then you will get almost a fair idea of what kind of questions are going to come. Majority of the questions will be having a relook of the assignments or weekly quizzes. So I request you to thoroughly practice and work out all the weekly quizzes. Detailed solutions are already uploaded. Kindly work on it. And marks split up, all are short answer type or numerical answer type. There is no long essay type questions and all are short answer type. Some are true or false kind of thing. Then the split up of mark is a few of the questions are directly recalling from the video. So if you carefully go through the video and attend the slides, you may be able to answer 20 to 30 questions. And then some are based on assignments and some are slightly on the upper level thinking, so that we will be able to categorize students into high performance, low performance, and medium. So that's all about the pattern of questions. So kindly work on these questions. I hope you have seen there is a special lecture. So with that, we complete all these questions that are come live now and that are being already added by the students in the last week. Now, if anybody wanted to add any more questions, feel free to add it. We will be having a little bit more time that is pending. We'll be very happy to address your concerns. In the meantime, when our backend team is going to compile our work, I will tell about a few things regarding scope of further study in this area. So people have raised questions like, what is the scope of the field of computer architecture? So computer architecture is a very promising area, and especially when India is looking for making India's own processor, we require a lot of architects or engineers who have a fair background of computer architecture, knowing about how processor and caches works. So knowing about architecture, the understanding and appreciating the working of processor and cache is very much needed. So I urge you to take studying this course on a serious note. Then we are open for collaboration with institutes. So I will give chances for few students to work in our research group. If you wanted to have summer internship with us, and of course it is based upon the performance in this course. So those who are really good, doing good, we will be happy to offer them a few, not all of them. The toppers, we will give you some offers if you wanted to further work on research topics related to computer architecture. And students who are in the UG course, I urge you to consider writing GATE exam or GRE exam and study further for a master's level course. And those who are at the master's level, it is a good opportunity to study further for a doctoral level course. And few other updates from our research group. So our research group at IIT Guwahati in computer architecture, we are going to float a 1 week computer architecture, advanced computer architecture course by the TechCube 3, sponsored by the MHRD, and that comes from 10th December to 14th December. It's a 5-day full program, and the details are actually put up in my webpage. You can go to my webpage, www.iitg.ac.in/John Jose. So you will get a TechCube course, and it's a 1 week course. I urge candidates, if you wanted to get a concise idea and to know more about the kind of research that happens in IIT Guwahati, feel free to attend this course. It happens in IIT Guwahati campus in the month of December. It's from a Monday to Friday. So there is a one request that has come just now. Can you summarize this whole course about? Whether this request is specifically about our NPTEL course that is live or the TechCube course. Okay, so this is with regard to the NPTEL course. We just started with advanced pipeline, wherein processors are basically trying to execute task, and task is nothing but sequence of the instruction. So we started our course by concepts in instruction pipeline, and then we slowly moved on to superscalar architectures where you can fetch and decode multiple instructions. We have seen floating point pipelines, and that was a brief, just 3 lectures was only spent for the processor side. Since the course was more specific onto storage and then interconnects, very few lectures were spent in the processor side. And then we started trying to understand what is the role of memory. And memory in terms of the hierarchy of memory, we have caches, we have main memory. We had a deeper looking into optimizations in cache and about the main memory, its organization, its scheduling. And we learned about what you mean by TCMP, tiled chip multi-core architectures, and what is the role of the interconnect structure, network on chip, routing, flow control, and what is the role of NOC for larger chip multi-core systems. And we have seen a couple of quality improvement mechanisms like application throttling, application mapping, energy efficient routers, minimally buffered routers. So all these at the end were giving you a capsule idea of how important the on-chip cache and on-chip the interconnects is about this course. So we got a request from Nandini whether memory architectures like 3D NAND flash can be included in this course. Yeah, that's a good suggestion. Probably in the subsequent run of this course, we will consider about adding more about the latest emerging memory technologies like 3D NAND, then flash memories, non-volatile memories and all. Probably in that case, a 20-week lecture may not be sufficient. We may have to extend it to 30-week lecture. Of course, we are very happy to incorporate the suggestion from the candidates. So do you have any more questions from any more candidates? We'll wait for a few more minutes and then see. Okay, so for candidates who are seriously considering about and writing the exams, at the end, you need to get 40% mark to get the certificate. And beyond a threshold level, you will be called it as gold certificate and the elite certificate. And of course, that carries a value. It's a stamping that you got more than 80% mark or more than 60% mark. So kindly go through the videos well. The slides are already being shared. And prepare all the assignment questions. I am repeatedly telling, work through all the assignment questions and then practice well and come for the exam. And few students have already submitted the 3rd and 6th assignment in GEM5. So knowing an architecture simulator is really a skill. So I urge students who wanted to further work on this domain to explore GEM5, spend some time. There are a lot of online forums in Gem5. Try to be a part of this Gem5 online forum, and then attend more number of this kind of programs that is been done. If you wanted any specific assignment pertaining to code editing in Gem5, kindly drop us a mail. We will share with you some of the assignments that you can work on. So with that, we are going to conclude from our side. Do we have any more questions? Okay, so I congratulate all the candidates who have worked with us in the last 8 weeks, trying to learn about a new topic about multi-core computer architecture, storage, and interconnects. A video was added in this course by my senior colleague, Professor Hemangi Kapoor. She was giving you a broader overview about, after taking this course, what next? What are the probable areas that you could further work for your projects for BTech or MTech or research topics? So IIT Guwahati has a very vibrant computer architecture and VLSI group. Close to 7 or 8 faculty are working in this. And we are looking for PhD scholars. We are looking for postgraduate students. Kindly do apply and be a part of our team. We will be very happy to associate with some of the bright minds in the country. So to conclude, I thank all my backend support team, my PhD scholars from my lab, who have been continuously working throughout this 8 course. And they were able to give you the live updates about your queries. So I thank especially my PhD scholars, Deepika Deb and Abhijit Das, for the live support they have given for all the queries that you have put in. So I wish all the candidates the very best. Kindly do attend maximum number of these kind of courses and get benefited, and try to study as much as possible. Wish you good luck. Thank you very much.